So note 7 is confidence interval for difference in proportions. It says, recall comparing two proportions. So what we did a while back. It says comparing two proportions based on a random sampling or randomized experiment is one of the most common situations encountered in a statistical practice. We see this when we're trying to determine whether two treatments caused an observed difference, so like in an experiment, or if we want to draw a conclusion about the population for all subjects. So this is the most common type of statistics because in general, when we are trying to test something or ask a question, we want to compare two different things, okay? And in the example that we're about to do at the end of this is we're comparing teenagers versus adults. Who has more social media, right? That is a more common practice than just comparing and looking at one proportion. Okay. So recall sampling distribution of P1 hat minus P2 hat. P1 hat is the sample proportion for the first group, and P2 hat is the sample proportion for the second group. Caught that on video too. Okay, so for one proportion versus two proportions, we're still looking at the same shape, center, and spread. So when you see these are our conditions. So shape is talking about normal. Center is talking about random. And spread is talking about independence. Okay. So for the shape, we still want this to be approximately normal. In order to conclude if it's approximately normal, we have to use which condition? Large counts condition. So large counts. Okay, the only difference is we cannot just do it for one sample size. We have to do it for both sample size. So this would be N1 P1 is greater than or equal to 10. N1 times 1 minus P1 greater than or equal to 10. So that would be like the first sample, so let's say teens. And then we would have the second sample, N2 P2 greater than or equal to 10. And N2 times 1 minus P2 greater than or equal to 10. And that would say adults, right, are two different proportions. Okay. For center, or our random, remember this tells us what mu is. So mu of P1 hat minus P2 hat is the same as just saying P1 minus P2. Okay. We prove that something is random, okay, if what? Not the 10% condition. So when we're proving random for our conditions, we're checking what? Yes, if we're making sure that our samples are randomly selected. So both, that would be the only difference here. Both samples randomly selected, or we could say randomly what? Assigned if it was an experiment. And then last for independence, that is determining standard deviation. So sigma of P1 hat minus P2 hat is equal to the square root of P1 times 1 minus P1 over N1 plus P2 times 1 minus P2 sorry, I'm running out of room here, over N2. Okay. Yes. Okay, so again, let me see if I can move it some. We'll do it like that. Okay. Better, easier to read. Again, these look like a lot, but we don't need to memorize these because these are where? On the formula sheet. And it is something that we've already seen before. Okay, we're just putting it in terms of confidence intervals and significance tests. It's still the same mu and sigma. And then in order to prove independence, we have to use what? Which condition? 10%. And again, the only difference is we have to compare it for both sample sizes. So we have to say that sample 1 is less than or equal to 10% of population 1, and sample 2 is less than 10% of population 2. So again, none of this right here is new. We've done this a few times already on different notes. Okay, talked about the 10% condition, large counts condition, and more specifically those formulas for each of them. We're just now adding a different proportion, sample proportion. So it says confidence interval for difference between two proportions. So remember, on your formula chart, it's going to give you this formula in words. And remember, the reason for that is it changes when we're talking about different things. So the formula is the statistic plus or minus the critical value times the standard deviation. Okay. If we're talking more specifically about the confidence interval for the difference in proportions, this would be P1 hat minus P2 hat, that's the statistic, plus or minus Z star, that's the critical value, times the square root of P1 hat times 1 minus P1 hat over N1, plus P2 hat times 1 minus P2 hat all over N2. Okay, and that's the standard deviation, the same formula that we wrote above, but talking more specifically about P1 hat and P2 hat. Okay. And then the last thing here talks about that critical value. It says, remember, the critical value is Z star. That is for the standard normal curve. And when we look at the C percentage or the percentile, it's looking between, or the area between those two critical values. Okay. However, when we look at Z star, we're only looking at which one? Positive. Okay, we can ignore the negative. We're only looking at the positive one. Okay, any questions so far? Okay, you're going to see what this looks like in a FRQ. Okay, so it says a recent survey wanted to compare the proportion of teenagers and adults who use social media. The first poll, so you're going to need two different color highlighters. The first poll says a random sample of 300 teenagers. The second poll is a random sample of 400 adults, and whether or not they use social media. It said 92% of teenagers use social media versus 75% of adults. It wants us to construct and interpret a 95% confidence interval for the difference between the proportions of U.S. teens and adults who use social media. Okay? In all the FRQs, we always start with what? Our 4 C's. And good job, everybody who did the FRQ. Nobody forgot the 4 C's. So you guys are doing great on that. Okay, even if you could not do the FRQ and you wrote your 4 C's, you got 4 points. Because I want you to write it. So our first C is communicate, and that's where we're going to write both our proportions. So proportion 1 is going to be the proportion of teens who use social media. Okay. P2 is going to be what? Proportion of adults, good, who use social media. Okay, the other thing we need is our confidence interval, which they said was what? 95%, which we could find our Z star value, which is 1.96. And remember, we find that Z star value using the standard normal distribution on Desmos. Okay, you go to the normal curve, put in 0 for mu, 1 for standard deviation, and you go to bounds, and you type in 0.95, you get 1.96. Or you can memorize them. Good. It's always going to be the same. So if you memorize them, even better. Okay, our next is our conditions. So our conditions, we have random, independent, and normal. For random, we need to write or check what? For random, that both samples are randomly selected. That's all we got to write. Okay. For independence, what condition is that? %. Okay, we gotta memorize those. So if you're having trouble, I would do some studying. Okay, so we have 300 times 300 is less than or equal to 10% of all teens. I'm not gonna have enough room. I should write it here. Okay, so all teens. And then we have 400 is less than or equal to 10% of all adults. That's us checking both samples. Okay, for normal is the large counts condition. And that is where we need to check the N1 times P1 and see if that's greater than or equal to 10, and N1 times 1 minus P1 greater than or equal to 10, and then also for the other sample. So 300 times 0.92 is greater than or equal to 10. 300 times 1 minus 0.92 greater than or equal to 10. 400 times 0.75 greater than or equal to 10. And 400 times 1 minus 0.75 greater than or equal to 10. You do not need to simplify that 1 minus. Okay, so if you are not confident in your math, either go to Desmos if you really want to simplify it, or just leave it. Okay, leave it alone. Okay, now we have our calculate. So let's see. Calculate. For calculate on the FRQ, you guys did a little bit too much. Okay, so a little bit too much. Remember, you only need your name. So this is a 2 proportion Z interval, and the answer, which is the interval, which I will show you how to get in just a moment on Desmos. Okay. And then the last thing you need is your conclusion, and I'm running out of space. Okay. So then the conclusion, since we're talking about a confidence interval, we say we are 95% confident that the true difference in proportion of teens and adults on social media is between 0.1176 and 0.2224. Okay. How we would solve this would be following, let me go a little bit, would be following those steps that I wrote above. Okay. You'll notice that the steps are exactly the same. The only difference is that instead of a 1 sample, we're using what? A 2 sample. That's the only difference. Okay. So to show you that on Desmos, okay, it is us following these steps here. So I'm going to go to add an inference. Okay. Still using z-test for proportions. And then notice how it says sample 1 and sample 2. Well, for sample 1, I'm going to type in what I got for teens. So for teens was, let's see, 300, and then it said 92%. So that means I would have to calculate what is 92% of 300. 276? So that means 276 is my successes and 300 is my sample size. Then I would go to sample 2 and I would have to do what's 400 times 0.75? 300? So then for the adults, I would say 300 is my successes and my sample size is 400. So in this problem, they don't outright give you the successes. They just give you the percentage. So you had to actually calculate this. So this is X1, this is X2 for successes of the teens, successes of the adults. When you type all that in, you hit generate tests. Okay. You go to confidence interval, because that's what we're calculating. And what confidence level are we using? 0.95. And then that's where I got this interval here for our answer. So they rounded it 1 more. So I should just say 118 and 0.222. Same thing. Okay, it rounded it 1 more. That's why I like if you use Desmos more. These, of course, are the calculations using the calculator last year. Okay, so that's how you would find that answer. Any questions?